So just as a final note for the weak acid, weak base, or strong acid, sorry, weak acid, strong base titration. If we look at our titration curve, pH versus volume of titrant. So again, our equivalence point happens at 10. Now, because we were titrating a weak acid, our pH starts low and will go high. And we're going to have a sort of similar shape to our curve. It won't be quite as steep as it was for the strong acid, strong base. And just to remember sort of what's happening at each point. At the beginning of the titration, we just have our weak acid in solution. And so we know how to solve that, right? That's going to be Ka equals x squared over f minus x, just controlled by the Ka. In this whole region here, before the equivalence point, we have a buffer because our weak acid is being converted into a weak base, and so you have a solution with both of those present, which is the definition of a buffer. And so we'll solve that with the buffer. Then here we have at the equivalence point, we get this very sharp change in pH, which is what allows us to observe the endpoint. And this will be our a solution of just weak base because all our acid has been turned into base. And so you'll find the pH using this, x squared over f prime minus x is equal to kb. And then we have, after the equivalence point, we have just our excess titrant that's controlling the pH. Now, if we do this with a weak base instead of a weak acid, everything will look very similar, except for that you'll start with base and do it that way. But you'll still start with a weak base, have a buffer region at the equivalence point, then you'll have just a weak acid that's present, and still you'll have excess titrant at the end. But otherwise, things look basically the same for titrating a weak base, pun not intended.